So some examples from section 8.3, number 6, how much homework. So administrators at your school want to estimate how much time students spend on homework on average during a typical week. They want to estimate mu at the 90% confidence level with a margin of error of at most 30 minutes. A pilot study indicated that the standard deviation of time spent on homework per week is about 154 minutes. So you actually do know the population standard deviation in this case. It's not always true. How many students need to be surveyed to estimate the mean number of minutes spent on homework per week with a 90% confidence and margin of error at most 30 minutes? Okay, so for number 6, some extra examples. Number 6. We are going to use this part. We're going to use z-star standard deviation over square root sample size less than equal to the margin of error. So how do we find, let's just review how we find z-star. So we want 90% confidence interval. So that leaves how much on the tails? 90%. So we have 5% on the tails. So we're going to look up in your table A, and the z-score should be for that negative 1.645. So you can look up 0.05 in table A. So our formula looks like 1.645 times standard deviation 154 over square root of n, and we want that to be less than equal to 30. So we solve for n, and you should get n greater than equal to 71.3. So to be on the safe side for our margin of error, we round up. So you would say the administrators need to survey at least 72 students. The administrators need to survey at least 72 students. Okay, not that much new there. Just using a different formula. Okay, so for 7, we are, how do you find T star using table B is this question. So for 7 we have assuming the conditions are met, suppose you want to construct a 90% confidence interval for the mean mu of a normal population based on a simple random sample of size 10. What critical value T star should you use? So this is how you do that for 7. Okay, so the degrees of freedom, since the sample size is, okay, so sample size equals 10. So the degrees of freedom, I'll abbreviate DF, degrees of freedom equals 9, equals 10 minus 1 equals 9. And then we want to use, what's the tail probability? Use column 5%, column with tail probability of 0.05. Okay, so the critical value T star equals, and so here's table B. It's even easier to use than table A. So what you'll see when you use this, we're looking for degrees of freedom of 9. So over to the left you'll see DF, and you want 9, and then you go over to tail probability of 0.05, and you see 1.833 there. And you can also look down at the bottom. It says the confidence level at the bottom is 90%, so you don't even need to do the 0.05. But so that's how you look that up there. And so the T distribution, it looks like a normal distribution except the tails are fatter. And so you would get T star equals, what did we just say? Thank you, 1.833. So you could do that, or on your calculator, or use this inverse T on your calculator. You would type in 0.05 for that tail probability, and then you would put the degrees of freedom, and that should give you the same thing. And finally, number 8, can you spare a square? We're going to do a complete state plan do conclude for a confidence interval. So here's 8, and I should have written in the question here. So maybe I'll do that on here. You should have been given the actual question. So let's just read it quickly. So as part of their final project in AP Stats, Christina and Rachel randomly selected 18 rolls of a generic brand of toilet paper to measure how well this brand could absorb water. To do this, they poured a 1/4 cup of water onto a hard surface and counted how many squares it took to completely absorb the water. Here are the results from their 18 rolls. Well, there's no question here. So the state should be, we want to estimate mu, which equals the mean number of squares, the mean number of squares of generic TP needed to absorb a 1/4 cup with 99% confidence for this problem. You would be given that. Okay, so now the plan is to construct a 1 sample T interval. Construct a 1 sample T interval provided our 3 conditions are met. Okay, so number 1, random. It was taken from a random sample, so I'm just gonna write random check. Normal. Okay, so this is a little bit more involved here because our sample size is smaller than 30. So okay, so since the sample size is small, it's 18, and we don't know the population is normally distributed, we need to check the data. We need to check and look at the data to see if it's close to normal. So we need to check data by graphing it. So you could do a box plot or a dot plot is what we're going to do. And if you did that, let's see here, 20, 21, 22, I'll label every 2, 23, 24, 25, 26, 27, 28, 29, 30, and I plotted the data that we have. We have a, correct me if I'm wrong, but we have a 20, we have a 20, 2 21s, a 22, a 23, 3 of these, 3 25s, 1 26, 27, 28, 29. Okay, so the dot plot doesn't show any outliers or strong skewness, so it's still reasonable to assume the population is approximately normal. So let's see, we don't see, so no outliers or strong skewness, so reasonable to assume population is approximately normal. Is approximately normal. Okay. And then independent, same as before. Independent. It'd be reasonable to believe there's at least 180 rolls of generic toilet paper. So we assume greater than 10 times 18, 180 rolls of generic TP. Okay, so we're ready to do. X bar you would find by typing in the numbers on your calculator and finding the sample average of the numbers given. So that will come out to be 24.94. And the standard deviation you can also just do on your calculator. So standard deviation of that sample, S sub x, is 2.86, should be. The degrees of freedom are sample size is, there should be 18 rolls there, so degrees of freedom are 17. And we have a 99% confidence level. So T star, if we look in our table, would give us 2.898, and we could look together here. Degrees of freedom, 17, and then confidence level of 99%. So that leaves 1% in the tails, so it should give us 2.898. There we go, right here. 5%, and sorry, what do we have? 99% leaves us a 0.5% in each tail. Okay, so then we take these values and we plug it into this formula. So we have X bar plus or minus T star S sub x over square root of n. So we have 24.9 plus or minus 2.898 times 2.86 over the square root of 18, and that gives us 24.9 plus or minus 1.95. So we would conclude that we are 99% confident, that the interval from 22.99 squares of toilet paper to 26.89 squares captures captures the true mean number of squares. Captures the true mean number of squares needed to absorb quarter cup of water. Quarter cup of